Okay, everyone, welcome to part one of Get Started with Essential Chemistry. This webinar will cover the program components of the Essential Chemistry curriculum, including the student and teacher textbook and the included student and teacher lab book. We are not going to be going into depth at all on the sensors and equipment in this session. That will be in part two session. So the uh, if you can't make part two, you can always register for a later session. Just check pasco.com/training for our upcoming webinars, or if you're watching this later, you can always look at the recording. It'll be posted up there on that link. All right, if you've got your smartphone with you, go ahead and scan that QR code. That'll take you to the materials for this presentation, which is really just the presentation that you're looking at. It's the PowerPoint. So if you wanted to get a copy of the PowerPoint you're looking at, go ahead and go there. And I'm going to, I've already, um, you've already got that QR code, or you can go straight to bit.ly/get-started-EC1. This is case sensitive, so you want to use capital E, capital C. So let's talk about what's the Essential Chemistry program all about. Well, it is curriculum for high school chemistry. So there is a digital student textbook, a digital teacher textbook that are each individually licensed. And the digital books work on any device, smartphone, computer, tablet, what have you. The ebook works. It is browser based, so it can do anything that anything else in a browser can do, such as you can copy paste text. You can turn on your translation, like if you have Google, if you're using Google Chrome, you can turn on the speech translation to whatever language your preference is. There's a optional print book, and that goes for the student book only, an optional print student book, as well as an optional print lab book, either student or teacher. And the student print lab book is consumable. So students can tear out worksheets and write answers right there in their lab book. Okay, there's also optional equipment kits. So I'll be talking more about those in session two. And when you sign up, when you get a license for the ebook, you may or may not also be a portal subscriber. The PASCO portal is a subscription service which just makes sharing documents and accessing documents and getting them to your students easier. And that is a subscription service that is separate from the ebook. But every now and then you'll be hearing me talk about portal. I'll even go there in a couple instances to show you how the materials are organized in the regular ebook versus if you're a portal subscriber. Whether you're a portal subscriber or a standard ebook user, the program comes with a digital teacher ebook, and there are resources in the teacher ebook. You can see in the screenshot here on the left side, and we'll be going into more detail on these later. There are PDF and editable Word doc and editable PowerPoint versions of all of the resources, including the presentations, student assignments, answer keys, sample data, and so on. All the stuff is found in an editable form. There's also some teacher tips here, and we're looking at a screenshot here of the teacher ebook. This will only appear in the teacher version. You'll see this left side sidebar that is yellow, and students can't see that. We'll talk more about teacher resources later on. More teacher resources that are available via either traditional digital ebook or going through Portal is an infinite test bank. And by the way, if you're a Portal subscriber, the teacher ebook and infinite test bank, these are included with your Portal subscription, whether or not you've purchased a ebook license. So the infinite test bank, and the word infinite is meaningful, and I will go over what that means in detail later. But what it means is you have a question on the exam or a quiz, and it's quantitative, so there's numeric values. Every time you generate a different version of that test, it will generate a different number, which means you can generate 30 or 40. Why would you do that? But you could generate 30 or 40 different copies, like one copy of a test for each student, and each student would get different quantities in their quantitative uh, assessment questions so that there's no cheating. They would all get individual questions. And that goes for the quantitative questions. Then PASCO Chemistry Academy is included either as a portal subscription or if you have just the standard Essential Chemistry digital license. So what PASCO Chemistry Academy is, it's support for you and your students. It was originally designed for teachers to be able to do lab activities with their students online during the pandemic. And you'll even see some of the videos are wearing masks. But it turns out that it's just a really great resource, not only for you to learn if you want to know more about how do I do this lab? I've never done this kind of lab before, or how do I use this sensor, or I don't have that sensor. Maybe I can look at how would a lab look with that sensor. And I'll talk more again about that PASCO Academy later on, just introducing the components of the program here. And SparkView software, this is the software that would work with our sensors for data collection and analysis. And that's all of the SparkView software stuff will be in session 2, part 2. Okay. So moving on. Before we get started with just diving into all the features of the book, I want to share with you what might a typical student experience look like, or how can you use the resources in essential chemistry in a way to make a lesson more engaging and uh, more fun for students. So here's an example of a way you might approach heading into chapter 11 in the first lesson with the mindset that, oh, I'm going to do the investigation. We're going to do the lab for that session, but how is students going to be prepared to do that lab? There's a number of ways you could approach this. You might do any of these things here in the bulleted items in any order to eventually get to the lab. And that means students might be reading chapter 11, lesson 1. So here's the student version of chapter 11. So maybe students are reading through this lesson. Let me make this a little bigger. So they read the first couple of pages. Maybe that's all you assign. And then you ask them to go ahead and do the interactive simulation that they see at the bottom. It's described. It tells them what to look for in the simulation. In the ebook, this button can be clicked to open the simulation. It tells students what to look for, but this is really an opportunity for students to learn by doing, look for the patterns before they're instructed on anything, just to see what happens, to get their own ideas of patterns. So let's say that there's some particles that I need to, let me zoom a little bit more there. Let's just run it how it's set up originally. So we've got the model for polar molecules is turned on, and this is students would have already, chapter 11, students would have already gone through chemical bonding. So they'll be learning about intermolecular forces in this chapter. So now they know a little bit about polar and nonpolar, but they might not know much about the attraction between particles and on the bulk scale, what happens when you have a whole bunch of polar particles together, how do they behave under different conditions compared to nonpolar particles. So let's see what happens when we heat up these polar particles. Ooh, they start moving. That's probably a liquid because some particles are rolling over one another. Some are breaking free, but they're coming back. So it's almost like it's evaporating and then recondensing a little bit. Just a few particles can do that. Oh, there goes one, but it made it back. So this is a liquid that's warm. What if we put a bunch of heat in there? Oh, now we've got a lot of motion. We still have some liquid. And particles do go into the vapor phase and they stay into the air a little bit longer. And if I'm looking closely, if I turn on slow motion, I can see positive and negative attractions, these little dotted lines that go away, unlike the solid lines between the bonds in the positive and negative particle. So let's turn off slow motion. Let's put even more heat on there. And I'm going to eventually get a phase change where pretty much all the particles are going to the gas phase. So that's interesting. And then they do the same with nonpolar. And they will notice that there are particle attractions, but just at the beginning, even I already see that there are a lot more particles that want to vaporize and most of the time recondensing. And all I have to do is add a little bit more heat to get them already into the gas phase. So that's something that they can pick up on before they even do the lab. So that might be the first thing they do. Then or the second thing they do. So they're reading, they get to the end of their 2-page reading assignment, they get to the simulation for polar and non-polar particles, then they start the lab investigation. And the labs in essential chemistry, there are over 70 of them, and they are a mix of traditional labs and sensor-based labs, almost half and half. So we got you covered if you don't have the equipment kit, but it definitely has more depth with the sensor-based investigation. So I'm going to switch my camera over to my lab setup. There we go. Now, this lab begins with students looking at water versus alcohol. The stuff in the background here, that's all essential chemistry kit stuff. So you may or may not have that stuff in the back if you have essential chemistry, but you definitely have the part of the lab that says, take some water, take some isopropyl alcohol, and now I'm going to open them. I had them covered because I didn't want them to prematurely evaporate under the warm lights here. So take a cotton ball, dip it in the water, dab it a little on the side. Oops. And wipe the cotton ball on your arm and describe what that feels like. So here's some qualitative experience. They're experiencing what's happening here, and student lab partners would describe each other what they feel. Then they do the same thing with a different substance, isopropyl alcohol. The higher the percentage, the better. On the opposite arm, so they wipe some on the inside of the arm, and they qualitatively experience the difference between these two substances. What does that feel like? Wow, that's a lot cooler than this arm felt. So with water, I felt my arm cool down, and it's still kind of wet, but when I went with the isopropyl alcohol, it felt a lot cooler. But that cooling didn't last as long. It's like it evaporated faster. So the different substances have different properties that we can experience. And then from there, you might go to part two if you have the lab equipment, the sensor-based stuff. So when we do part two of the presentation, we're going to follow this same lab into part two that uses the sensors. But if you didn't have equipment, you could go ahead and just do the qualitative part that we just did. And students would still gain something out of that. So meanwhile, whether or not you have equipment, when you go and do the lab, so let me quickly go to that lab. So I've just entered the lab book very quickly and easily from the textbook. I have access to the Molecule Viewer Interactive. I click the interactive button and I open it up, and I can open up isopropyl alcohol. And I can look at that molecule. I can turn on the charge surface. We're going to play with this a little bit more later on when I talk more about the interactives in the ebook. But I can look at isopropyl alcohol, and then I can switch to water. And whoops, I can switch to water and make comparisons about the molecular structure. Okay, or I can build the molecules with the kit, which is what the lab says to do. So that's just an example of how you might enhance a lesson with not only the content in the book, but also interactives, a simulation-based interactive where students explore the phenomena, and also the molecule viewer, and then the lab itself. So moving on. What's in the book? Here are the 8 units in the book. They are 24 chapters split among these 8 units. And the end of each unit, there is an assessment that integrates the 3 dimensions of science. So it's not just the content, but it's also the engineering and design processes as well as mathematics. So integrated assessments at the end of each unit, as well as design options for engineering and design projects in the lab book, in addition to traditional and sensor-based labs. Every chapter has a few sections, at least 2 up to 4 sections. And for simplicity, we've called sections lessons, even though we realize a lesson is not a one lesson. It can take multiple days. And the textbook itself has over 800 pages. The textbook and the ebook are the pages will be the same. So if you open up the textbook to page 144, it will be the same as the ebook on page 144. So let me just open a random page here. Okay, I've opened up to page 237 in my textbook. So if I close this and if I go back to my textbook and I jump to page 244, or sorry, this is 237. 237, I can jump to that same page, and I have the same content in the ebook as I have in the um, print book, student edition. So let me switch my camera back. Okay, I'll get that out of the way for you. So yeah, pages are identical, but you will, let me switch back to my other camera very quickly. You'll notice that the interactive simulation button does appear in the print book. So even though obviously you can't click it on the print book, students know if they go to the ebook and they go to page 237, they know, oh, if I jump to that page, I want to click this thing and see what it does, or I can click this thing and see what it does. So there's a visual cue of when there's additional content um, for simulations. Okay. Alrighty. Now, the student ebook, how do you get there? There are a couple different ways. If you're a portal subscriber, you would go in a different way than an ebook subscriber. I'm just going to show, first of all, just showing ebook, and then I'll jump over to portal in a second. So you would go to the website education.pasco.com, and that's how you would get to the student ebook or the teacher ebook. And then you will see this page. It asks you to enter an access code. It will let you look at either physics or chemistry, but if you have the chemistry code, you would go to the access code and drop it in the chemistry box. Teachers and students go to the same place. It's the access code that determines whether it's going to display the student edition or the teacher edition. So that simplifies it. Everybody goes to the same website. Then when you click in the box to enter a code, you drop the code in, and then you would click the open book button. And this is what it would look like if you had both. Let's say that you got signed into a teacher account for physics and a student account for chemistry. You can do that if you taught both chemistry and physics. So that's how you would handle that. But we are just going to be looking at chemistry. So we've gone to education.pasco.com. We've entered the access code, and then you can now open the book. And this is what the student edition looks like. It says student on there. So you can always tell which one it is. The other way you could tell, there's more than one way to tell whether you're in the student book or the teacher book. Not only would it say teacher here, but you will also have more buttons. And when we get to when we start talking about the teacher edition, I will be working from a teacher code. So now here's what it looks like when you open the book from education.pasco.com. Now I'm going to go back and we're going to look at the portal. So here's the portal. I'm signed into the portal. And I would go to the curriculum piece, and I would choose out of the curriculum PASCO Essential Science. Later on, we're going to talk about PASCO Academy. You also go to curriculum when you want to get Academy. And this is the first time, let's say the first time you've logged on to your portal account, it's going to default to physics, but all you have to do is touch the tab to get over to the chemistry stuff. And then from here, here is where you would get the student information on the right side to get the access codes for students if you subscribe to the student ebook. But the teacher content will be available for you automatically if you're a portal subscriber. Later on, we're going to go to the test bank. Here's where you would get the test bank as well. And if you wanted to see all the resources in the ebook, you would hit the View Chapter Resources button. We're going to come back to that later. But I'm going to switch back, and let's say if you went to the Launch Student ebook link, you would go to this page. It would take you to this page, and now we're on the same page we were before. We're now on education.pasco.com looking at the student ebook. So eventually it goes to the same place to get the student ebook. So from here, we're just going to look at the ebook on this link. So making it even easier is all the students at the school or school district will have the same access code. So sharing the information to your students is pretty easy. And the code is licensed for whatever number of years the adoption length was purchased for. If you wanted to learn more about Portal, I'm not going to be talking much more about Portal. I'm focusing on the ebook. So you'll go ahead and visit that link, that pasco.com/portal link, to learn more about what this is. What it is it's a way to easily share, securely and easily share documents through single sign-on or through your learning management system, whether it's Schoology or Blackboard or Canvas. It's also an easy way to get Google Doc and Google Slide versions of assignments that students can complete totally digitally through the Google Classroom. So more information, just please go to that website. Moving on back to education.pasco.com. What you saw here in the window when I went to education.pasco.com, we call this the home page. So this is just our landing page. It's the way to get into the ebook. You can either you can go to the um, um, what's the word I'm looking for? When you want to go inside the textbook, you can click the book button, and it takes you into the textbook. So the if I wanted to know what the interactives were in chapter 8, I might go to chapter 8 and then click the interactives button in chapter 8 to see just chapter 8 interactives. But if I wanted to know what were the interactives in the entire book, the home page is the place you go to see what's there for the entire book. What interactives are there for the entire book? Well, here I am on the home page. I'm clicking interactives. Oh, here's all the chapters. Here are all the interactives available. And interactives are those things that you click and students can click, play, do a simulation, look at an equation, look at a molecule. These are the whole book interactions. But if, again, I just want to see chapter 8, then I'm going to go into the book and go to chapter 8. Now that I'm in the book in a specific chapter, if I click interactives, I'm seeing what are just the chapter 8 interactives. Okay, so once inside the book, it limits you to the chapter resources. But if you want to see what's available the entire book, go back to the home button. So I click the home button and go back one, picture of the house. I went back home, and now these buttons, some of them will tell me for the whole book, where are these things? Labs, what are the labs in the entire book? Book, what are the chapters in the entire book? Okay, so if I hit book from the home page, here are all of my chapters and all of the units and a quick link to the appendix. I'll go back home. What are all the labs in the entire book? If I click the lab button from here, from the home page, here's all the lab chapters, and they're one-to-one aligned with the chapters in the ebook. So ebook chapter 5 and lab book chapter 5 are the same content, the same concepts rather. So it's easy to figure out which labs go with which lessons, and they're also pinpointed within each lesson which lab goes where. Okay, so let me go back to that home page. Where are all the chapter reviews in the entire book? That's what problems will do. We already looked at interactive STEM, science, technology, engineering, mathematics. These are quick shortcuts to high interest readings that are embedded in the book that maybe students might be looking for some kind of research question or they have a special interest. Here's a place to look to see where we've highlighted some of the most high interest content in each chapter. Okay, and so that's what STEM does. Jump, you saw me use that earlier. I can just type in there and put in any page and it'll go straight directly to that page. Elements, this is a special interactive that we'll spend some time going over in detail. Equations is another interactive that will, oh, I'm sorry, I misspoke. Elements is the periodic table. So it jumps to the periodic table with the same kinds of constants and ions and calculations, or equations rather, that you would expect to see on a student support sheet for, like when they're taking a test, you might give them a periodic table with equations and ions. So here's that, and also some constants for elements up to element 52. Okay, and equations, that's the simulation that we're going to spend some extra time. It's so special, it gets its own button. Appendix, your typical constants and quantities and conversions that you would expect in a chemistry book. So this book supports from basic to advanced level of chemistry. So you'll find things in here like, just looking at pH indicators versus Ka and the values for constants for acids and bases. Okay, so I think I've got you through all the buttons here. So that's how the home works. It's kind of a quick way to get anywhere in the book very fast, but the same thing is true when you're in the book. You can get anywhere fast if you just go to the book link. Let's say I'm in chapter 3. I want to see something in chapter 8. It's very easy to get to chapter 8. You just go up to the book link and navigate to 8. You can either click that first link to get to the beginning of the chapter, or you can open the sections menu and go to the individual parts of the book. Okay. So this slide summarizes what I just went over. Again, homepage, whole book, within a chapter, everything that's only in that chapter. Okay. The homepage is also a way to get between the ebook and the lab manual. You're just going to select the button book or select the button labs to whichever book you want to get to, ebook or lab manual. So how do you know, how do you get back to the home page? You just click the home button, whether you're in the lab book or in the ebook. Here we are in the lab book. Here's the screenshot from the lab book. I'm looking at a lab here, but if I wanted to get back to that main page, I just hit the home button. So, or I can switch between switch between textbook and lab book by just toggling the buttons within the book or lab. And how do you know whether you're in the lab book or the ebook? Here's how you do that. I can tell right now by looking at this screen that I am in the ebook, not lab book, because this little navigator here next to home, it says I'm in textbook, chapter 3. If I were in lab book, chapter 3, it would look a little different. So let's go to lab chapter 3. Now I'm in the lab book, so you'll get used to what labs look like. They've got the green title and the dotted line and some gray and orange section headers. So they all look like this to help you cue you that you're in the lab book, but also your little navigator here says it's lab 3.A. So the first lab that's in chapter 3 is 3A. The second lab is 3B, and the third lab is 3C, and so on. So we're in the lab book here. I want to go back to the book, and you can just click the book icon. And I've switched just like that back to the textbook. Okay. Moving on. Let's talk about the types of digital enhancements in the ebook. You've already seen a couple of them, right? We saw in section 11.1 what might it look like if you just were beginning a chapter. So I'm going to talk about from the student perspective here. The entire student ebook has audio narrations. These are in English. These little read aloud 1 paragraph at a time buttons are visible in the student book.
What's the matter? Is a question you might hear when someone wants to.
You may or may not have heard that. I just played it. It was narrating the text. But because this is a browser or HTML-based book, you can use your translator and it will read it in whatever language you've chosen. So that's the first digital enhancement is you can read it aloud either by clicking the button or using your screen reader. I'm going to go to chapter 8. It's just it's stoichiometry, and everybody's curious to see what does stoichiometry look like. Later on, we're going to be doing, in part 2, we'll be looking at a lab out of this section. So I'm just going to choose this section to review the digital features. So again, read aloud. I'm just going to scroll through the page and see what comes up. There's an interactive simulation button. So anytime you come across these, if you hover over them, you'll notice a little tag come up. So this label says limiting reactant simulation. Okay, so simulation is like what you saw with the polar and nonpolar particle attractions, where students can turn dials, click off and on parameters and see what happens. So anytime you see simulation, that's what that is. When I want to go to another page in this ebook, I'm on up right now a Windows computer, I can use my arrow keys on the keyboard. If I have a touch screen, I can swipe left or right, or I can click the next page on the bottom button, or I can click the pages left or right at the top. So there's several different ways to get page to page. I've gone to the next page, and what we have here, it's on the blue title here. It's important to note that we've written this book so that every page covers 1 topic per page. So if you're looking at a topic and it's like, you know what, that's advanced, I'm not going to cover that in this class, you can skip it without consequence to the next page. Unless it's something that's, that's integral, like you can't skip mole and be okay in the rest of that section. But maybe you can skip kinetics, when you're in that chapter, and maybe you just want to look at a little bit of reaction rate, but not the quantitative um, analysis there. So one topic per page. Here we are. We have kind of a Cornell notes type of outline here. We've got a topic identifier on the left side of every paragraph, so a topic, and here's the content for that topic, all of it related to the major topic on the top of the page there. Right here, I see a More button. So if I hover over the More button, it tells me what information I might see. It says limiting reactants in algal blooms, or algal blooms, potato, potato. So I click open and I can read more about algae and algal blooms. And maybe that's something that means very meaningful to you because that's a thing happening in your community. So you can read more about that subject of interest here in the More paragraph, and you can collapse it by hitting that button. So I always encourage you, always click the More button. You never know what's there. Sometimes there is an animation. Sometimes there is a, hey, try this quick activity. And students and teachers benefit by clicking the More button to see what's there. Next, here's another interactive simulation. This time when I hover over it, I see a chemical named octane. Octane. I didn't see the word simulation in the hover over. That means it's something different. So it says octane, that's a chemical name. That means it's going to bring up that molecule viewer that you saw already with isopropyl alcohol. So let me bring up octane and let's look at it. I said we're going to play more with this. So now we're going to play a little bit in here. And so here's what comes up standard. I see the octane molecule. I can change it from ball and stick model because we want students to be thinking about what are these molecules really like? They're really not balls and sticks, right? They are, let's change the model to space fill. This is a space fill model where I get an idea of the 3D space that a molecule actually takes up and the fact that bonds are really electrical charges that take up space or act over a three-dimensional space. And I can rotate, if I click and drag, I can rotate the molecule to see all the way around it. I can zoom in to make it bigger. I can zoom out to make it smaller. If I turn on the charge surface, I can get an idea of whether it's polar or non-polar. So I've turned on the charge surface and now I'm looking at blue, gray, and red. Blue, gray, and red. Okay, so I see red on the hydrogens. I know hydrogen's positive, so red's probably on the positive side. I'm seeing blue. Blue's probably negative because that's the opposite, right? But if I see gray, that's probably neutral. That's my working idea. Let's see if that's true. Let's look at a different molecule. Okay. How about something like methanol? We've got an alcohol group on a methane. There's a methanol. And now when I look, I can definitely see, oh, there's a really red region here, a really blue region here, and super gray over here. I've got some polarity on this molecule. I've got a very positive region here, a very negative region here on the hydroxyl group here. But on the gray area, on the methane base, I've got gray. So this is probably non-polar side of the molecule, and this is the polar side. So that's what charge surface does for you. And for students too, they can look at, oh, what might be explaining the property that I'm looking at. Oh, let me look in the molecule viewer. We couldn't put every single molecule on the planet in this viewer, but we did put many of the molecules that students will be working with in the labs, and also molecules that they see or hear about a lot of the times every day, like methane. They hear about natural gas, and they can compare that to methanol and maybe make some predictions about how those molecules might be different based on their polarities. Okay, so that's the molecule viewer. And I'm going to keep going down this page to look at some more components. Well, here is a calculation. And we always go step by step in our calculations. We always show things crossing out. We always show units. We always put the chemical formula when it's identified. And we show when things cancel, and we're consistent with our setups, just like we want to see from students. We also round to sig figs, and that's consistent throughout the book as well. So it's always step by step when going through solving a problem. I'll go to the next page to look for more digital stuff. Some more, so here's a solved problem. When you see solved problem, this is a typical quantitative type question, or sometimes it's qualitative, it depends. So here is a sample problem broken down to help students think about, how do I approach solving this problem? First, let me identify what's asked. Let me identify what's given, and always reminding them, use the units there, put the units and put the substance. When you have that information, always identify it. What are the relationships that I think are important to be able to figure this out? I need the reaction because we're in the stoichiometry chapter. And then step by step solving the problem. So they get down to the bottom and it always reminds them, don't round until you get to the end when you're doing sig figs. And it shows what might come up in your calculator versus here's what I might round to when I have to round for sig figs, and then the final answer. So that's consistent throughout the book. Oh, I forgot to let's go back and look at what that simulation was. Now this simulation has a chemical equation. So it doesn't say the word simulation. It doesn't have a chemical name. It has an actual equation. That will bring up a different digital enhancement. Let me open it up. So it brings up that exact reaction that is in that problem. So let me close it and show you again. Where did I get that from? It was from this problem that has the iron aluminum reaction. If I open up that interactive again, there's that iron aluminum reaction, and it's already balanced. So you can begin using this tool early on before students even learn about mole ratios, or maybe when you're just teaching students to balance. That might be when you introduce this tool. In fact, let's go to that unit or the part of this chapter where you would introduce balancing. And actually, I believe that's in chapter 7, right? First section in chapter 7. So introducing chemical equations in this section and also balancing and introducing coefficients and so on. So maybe, here's a reaction. Maybe this is where you introduce the tool and you show how it's used. It's used to teach and learn. And you might be automatically thinking, oh, because I thought the same thing when we were designing the book, like students will totally cheat with this tool. Why are we doing this? But hold on. If students know how to cheat with this tool, that's not a bad thing. That means they understand chemistry well enough to be able to cheat with this tool. Let me show you what I mean. So while this equation is shown balanced, you can start with this tool by clicking from equation, click over to the balance button, and it shows this equation balanced and what balance means. It shows that when you put a coefficient of 2, that distributes to the hydrogen and puts 4 hydrogen atoms on the left side of the equation, which is visualized here as 4 hydrogen atoms. Then on the product side, again, you show that the 2 distributes to hydrogen, and that's what it means to be balanced. We've got the law of conservation of mass here is being followed because we got 4 hydrogens on either side, and the oxygens, 2 oxygens on either side as well when that 2 distributes. So if you wanted to show what happens when an equation has the wrong coefficient, let's put a coefficient of 3. That's not balanced. I'm following the law of conservation anymore. There's too much hydrogen to account for what's in the products. So, and if I take away all the coefficient completely from both terms, it shows that it begins as unbalanced. And this is just where you might begin using the tool. Now, let's look at something a little deeper here in chapter 7. You would also be looking at the types of reactions. So maybe you're looking at that. We know that students have a hard time switching ions, especially when they're polyatomic ions, and kind of distinguishing the coefficient from the subscript, and when does it stay put? When do we use parentheses? What about hydroxide? What about ammonium ion and all of that good stuff? Well, this tool also helps you help students see and work along as they're learning how to balance equations from the ground up. So let's just open that equation builder outside of any of these interactive simulation buttons. It's going to be here on the equations button. This is the one that I said was special. It's a simulation that you can use throughout the book. It's got a button so you can access it at any time. So when we go to that equations button, the default reaction is just water, so formation of water. So here's how, that was the same equation we looked at. I think it was, yeah, I think it was this, it might have been reversed, but it was the same reaction. Okay, so you can show that you can change the subscript. What's a subscript? Oh, the subscript is the number below. And I can add or remove numbers with the change subscript button. I can add compounds or elements to the reactant side of the equation if I click add reactant. It starts out with a box, a blank box. Let me just put a random element in there just so you can see what it looks like. I'm going to pick carbon. I've got now a pink triangle on the carbon, and that tells me if I hit add element, that's what's going to go in there. Heck, let's make this a hydrocarbon. Let's just for fun tag hydrogen now, and we're going to add that. And it put it with the carbon because I still had the carbon selected when I had the add element button. And what if I want the carbon to have a subscript? Then I can just select the carbon and I can add till I get to the number I want. What if I wanted the hydrogen first and not the carbon and I have them reversed? I can do the move element. So I have carbon selected. It says I can move it to the right. Awesome. So now I've switched the order, but wait, I didn't mean to do that. Let me move it back to the left. Okay. So that's how I can fix a mistake. I can always change the subscripts. I can add products. If I go to the product side, I can hit add product and put whatever I want in there. That was a mistake. Oops, I need to get rid of it. I can delete the term. So just always make sure that it's selected, and I can start out with a completely blank equation if I want as well. So you can start from scratch if you want to teach balancing that way. Now, what happens when you get all the way to doing stoichiometry or even just doing crisscross when you're doing chemical formulas? Here is how, let's, one of my favorite ones is to show is a double replacement with lead, and lead nitrate and potassium iodide. So let's get started there. You might have first seen this and being like, where's the rest of the periodic table? I just see the first 4 periods. Okay, well, here's how this works. Let's look for lead. Lead is not here. Well, that's because we can only display so much at a time, so that we wanted to make it big enough so that you could project this so students could see, like if you're teaching with it. So you got to switch that button down at the bottom to periods 5 through 7. So now I'm looking at the D block of the periodic table. And if I wanted to see the F block, I could click rare earth metals. So that's how we get through the whole periodic table. But a bonus, the ions are available as individual units. So maybe you want to start with teaching how ions are units by clicking the compounds and ions buttons to note that these are not on the periodic table because these are often, covalently bonded ions that always stick together and have a certain charge. And this is where you can begin helping students understand the difference between crisscrossing with a subscript when there's a polyatomic ion. So how would we work with polyatomic ions in this equation builder? Well, let's start with lead nitrate. So let's find lead. There's my lead. And nitrate. I could try and do nitrate this way. So I'm going to add I'm going to continue to add to that lead. If I try to do nitrate this way, that looks like lead nitrate, but when I start trying to balance it, it won't work out. I'm going to remove these terms and explain why. Let me remove the element just to get rid of the N and the O. Let me add my nitrate. Here's nitrate as a unit. Okay, and I want to add another reactant. It's going to be potassium iodide. So potassium, that's going to be in period 4. And iodine is outside of that. So let me add that. And now I'm ready to put products in. So I'm going to click that empty box, and I'm going to put potassium nitrate. Nitrate as an ion. And you notice how I put in lead nitrate and it didn't automatically crisscross for me? It didn't automatically take the 2 and put it outside of the nitrate parentheses. So that's why this is to teach and learn with. It lets you just kind of put the components that are there, and it lets you visualize balancing once you have all your components in there. So now I'm going to add the second product, lead iodide. That's in periods 5 through 7. Okay, so if I just was putting in the pieces, I'd get this. But I know I have to crisscross. I know that for lead, it's a +2, nitrate's a -1. I should crisscross that 2 down to the nitrate. And when I select the nitrate term and I change its subscript, it puts the parentheses for me. If I had left lead to nitrate or lead nitrate without using the ion, it would only put the subscript on the oxygen because it's looking at it element by element by element versus looking at it as an ion. And that's why you have to use the compounded ion term when you're putting an ion into your equation, because it'll never let you put that 2 around the entire ion. So now I can look at, oh, I forgot. Let me check and make sure that all of my crisscrossing's done correctly. K and I are correctly crisscrossed. KNO3, that's right. Except for lead, iodide, I need a subscript of 2 on the iodine. Now that I have the crisscrosses ready, and this program doesn't tell you if your crisscross is wrong, what'll happen is when you've got your equation and you go to the balance button, it'll never, ever, ever balance. So that's a clue of, oh, I must have done my crisscrossing wrong. So students can, instead of get frustrated, they can see, wait a minute, it's not balancing. What did I do wrong? Let me check my work. Let me go back to the equation and fix any mistakes I might have made. So they go back to balance, then they can go back to balance and look at the visualization and see, oh, I see nitrogen, I need to balance that on the product side. I can add, all I can do here on balancing, it doesn't let me change the subscripts. I cannot change the subscripts. Can't change the all I can do is add coefficients. So that's another way to learn of how to balance. If I add my coefficient to the nitrogen, now my ends are balanced and I can visually see, oh, my K and I've got to add the coefficient to them on this side on reactants. And now it's balanced and it shows law of conservation is followed. And once I'm balanced, suddenly I have access to stoichiometry and show me how. So if I click stoichiometry, it shows if you had the proportions of moles as the coefficients are given, it would show you what's the formula mass of the compound here in the gray boxes. What is the coefficient proportions for the moles in the balanced equation? And it shows you how many grams would you need of potassium nitrate to have 1 mole of it? How many grams is 2 moles of potassium iodide? So if you were actually trying to do this reaction and you wanted to get the actual 461 grams of lead to iodide, you'd have to react these amounts. So this starts to give students a sense of proportions and really what are coefficients instead of just plug and chug numbers and not understanding what's going on. They see the purpose of balancing as far as getting the products, making products as if they were trying to make potassium nitrate. Say if they were a factory and they want potassium nitrate. Let's say they needed to make 50 grams of potassium nitrate. So if I need 50 grams of potassium nitrate, that means I need these quantities of moles. And if they look at the proportion, it's the same 1 to 2 to 2 to 1 proportion. They see that, oh, obviously the formula mass won't change because that compound is that compound, but it also adjusts the amounts of the reactants and products, the reactants that would be required and the products produced if you were looking for just 50 grams of potassium nitrate. So this is also, you can also edit the number of moles. So let's put 6 moles here. If I put 6 moles here, you can ask students to make predictions. If I put 6 moles here, what are the moles everywhere else going to do? And hopefully they understand proportions and they'll say, well, let's see, I think it's going to be divided by 3 everywhere. And it is divided by 3 because that potassium iodide was a 2, and they can make predictions about what the moles would be and what that would do to the quantities on the bottom. So there's one way to look, another way to learn stoichiometry and really understand what you're doing when you're changing proportions or when you're trying to achieve certain masses. And then finally, the show me how. Now, the show me how, what it does is it just shows how do we convert from one quantity to the next. And it goes in the order presented here on the screen. Students can't tell it what order to show the steps of calculation or converting from one quantity to another. It just shows them as we go stepwise, left to right. How do I get the mole quantity here? How do I convert from the 2.3 moles of lead nitrate to get this quantity? Next, how do I get um, that lead nitrate? How do I get potassium nitrate from it? Well, how do I get the lead iodide from it? And so on. It just continues showing how to calculate and what you would need to do to set up to get the answer for the next cell. How do you get the answer for the next cell? So it's really just, it's really reiterating, how do I use moles as a conversion factor? What's the quantity? I have to set it up so it cancels. It's really just teaching how to think about setting up a problem rather than solving the problem for students. It's not doing that because you can't have, for example, if you're doing grams to grams, it's never going to show the 4 in a row setup. It's just going to go stepwise. So students can check their answers, but they're not going to be able to fake showing their work here. So again, if you wanted to cheat with this, which is what I do all the time, like I cheat with it because I'm like, I do need to make 50 grams of potassium nitrate, so I'll put 50 in there, but I would have had to know the quantities already ahead of that. If I do want to make 50 grams of potassium nitrate, I'm going to need these masses. I cheat with it. I understand chemistry well enough to cheat with it. Students are going to also have to understand chemistry well enough to cheat with it. So it's not a bad thing if they know how to do that. So I'm just going to go over this slide and make sure I covered all of the digital enhancements that I attended. See, there's one I forgot. Okay, let me go back to the book, and I was showing you 8.3. So vocabulary words. Okay, so here we are in the beginning of 8.3. So this is where we're talking about limiting and excess reactants. So students have already learned balancing and so on. You will see that there are bold words, and these bold words are the first time a vocabulary term is introduced in the book, or the first time in a long time the term is being introduced. So we assume students don't know this word. So you hover over it, and it shows briefly the definition, but if you click, it locks the definition. And you can play the
Limiting
definition aloud in English, or if you toggle the English button, it will go to Spanish and show the term in Spanish, and also read it aloud
Reactante
in Spanish.
limitante. La sustancia que se agota
Except it's just these two languages, English and Spanish. So the only Spanish you'll see in the book is on the vocab terms, but again, you can use that screen reader to read the terms. And this is also helpful because these critical words that probably your screen reader has never heard, doesn't know how to say, now in Spanish at least students can hear the pronunciation. And it's also nice, it's fun for me to teach myself some of these terms that I don't know. I don't know the technical terms in Spanish. And I can always hit that button to learn them. So this is where we were last, looking at more digital features. So we saw molecule viewer. Ammonia is going to give me molecular viewer. This is going to give me the equation builder because there's a chemical equation there. Here's my solved problem with all of this, everything set up as you would expect students to do. And here's a gray box that says test your knowledge. These gray test your knowledge boxes are only available in the ebook. They're not in the print book. And what these are, when you see these, encourage students to answer the question, because this is the checkpoint. It's hey, make sure you get this question right. Make sure you understand it if you didn't get it right, and understand what you did wrong before going forward. This is a key thing that you have to understand. You're going to be really confused if you keep going. So stop and try, look at this test your knowledge question. Always encourage students to do these. So it gives them the question. It asks them sometimes multiple part questions, and then students do the work, and then they click the show solution button to check their work. It gives them the answer because this is to learn with. It's for students to self-learn or check their understanding, and also know where is it they're getting stuck. Because maybe they got the first two lines of the solution correct, but then they get down to that third line and they're like, wait a minute, that's where I messed up. I don't understand. Help me. So you can always hide it that way. So these are built in. Every now and then you'll see them pop up in the student edition and teacher edition. Here we are at the end of a section. So section 3 review, it's just a summary as you would expect. There were only 2 vocabulary terms in this section. And then there's the review questions. So I remember when I was in school a long time ago, my teachers would always assign the end of section review problems for homework, which you can also do, but word of warning here. What we did in this ebook is on these review problems and questions, we gave students the answers. We did. So show solution, hide solution, because again, we expect students to use these for self-check, self-learning, make sure they understand. And they should be able to answer these questions once they get through the section. Now, that doesn't mean all the questions that we ask in the whole book they don't all have answers. Okay, I'll show you the questions that you can assign that don't have built-in answers for students, but end of section questions do have answers, every one of them. Okay, so, and they show the solution, just so you know that. Now, but what's nice about the end of section, every end of section has this button down here that says take a quiz. And if students click that take a quiz button, it gives them a quiz that's just similar to the section review questions, but different than the section review questions. So if they click that, they can put their name in there. You can assign this for homework, and students can give you a printout of their progress of their results if they hit the print button, and they can print to PDF if you're all digital, or they can print to paper if you do paper. So I'm going to randomly guess because I'm going to try and cheat. I'm going to put all A so it gives me the answers so I can see. Okay. So let me score it. Ooh, I did terribly there. I got 1 wrong. I got 2 wrong. I got 3 right. Good guess. 4 and 5 I got wrong. Every one I got wrong, it gave me a hint. So I can try again. Well, let's say that's not enough for me. I need a little more support. What if I hit show solution? It shows me what the right answer is. It does do that. However, let me try this again. I'm going to do a new one because my screen got locked there. So I hit new. Look, it gave me a whole different test. Sometimes the questions are completely different. Sometimes every time the choices are scrambled. The numbers, this question right here, the consider the reaction of methane burning, it gave me 8.6 moles here this time, but that wasn't the number last time. Let me refresh this quiz and show you. So let's next time look for the methane and 8.6 moles. Let's do new. Let's see, where's methane? There it is. Oh, look, 1.7 moles. That's a different quantity. Now, my choices are all different too, and all these numbers are reasonable based on the given 1.7 moles. Like you might have flipped something over, used the wrong quantity somewhere. They're all reasonable answers for a reasonable wrong setup, but there is obviously one right answer there. So yeah, kids can all day long click A every time and then look at the answer, but they're going to have to get a new quiz to be able to turn in something that doesn't show that they've cheated. So we've got one attempt here. Let's say, okay, 1 was correct. Let me guess on number 2, let me guess B. Okay, I'm just going to change that one. And 4, I'm going to guess B. 5, I guess I'll guess B again. Let me score it again. Oh, look, it says now I have 2 attempts on this quiz. It didn't change my quantities because I didn't ask for a new quiz. I just told it to score it again. I have the same quantities as before, but it's telling me 2 attempts, which is fine. Students are learning, right? Let them do another one, right? Okay, so fine, I'll guess C. Score, 3 attempts. D, and so on. So you can see how this works. It counts up, of course, it's the last one. So it counts up the number of attempts you have, and maybe your goal is for students to eventually get 100%. But it does keep track of how many times they've scored that version of that quiz, or they've taken 5 different versions of the quiz, because this is using the infinite term that I pointed out before. Infinite meaning making always making different quantities when it's a quantitative problem. So they'll have to recalculate the quantitative questions. And again, for the ones that are not quantitative, it'll mix up the choices and sometimes put different choices or entirely different questions for the same concept. So there's infinite quiz, which is nice because remember, you've got the answers to these questions, but not so much when you take a quiz. So there's the end of section. That's in every section in the whole book. Well, let's jump to the end of chapter problems. So if I hit the problems button, it jumps to the end of chapter. So first it starts with vocabulary. It's very easy. It's just matching. I mean, it's vocab, right? It's memorization. So it's easy. The next section, and it's by, what I mean by section is the type of question. So there's the vocabulary section, which gives the vocab for 8.1, 8.2, and 8.3. There are 3 sections in chapter 8. Then it moves on to conceptual questions. So now we've got chili peppers showing up. And these questions, students cannot see the answers for these questions. The closest they get is you've got matching on vocab, and that's it. That's the closest they're going to see to answers. Teacher edition only has answers to the concepts to the end of chapter questions. So these chili peppers mean something. If you see no chili peppers like the vocab, that means these are easy, these are memorization based, easiest you can do. If you see 1 chili pepper a little harder, 2 a little bit more, 3 is the hardest, so it's like a 0 through 4 difficulty scale in difficulty of the thinking level that would be required to get to an answer there. So if you wanted to send the quiz results, if the teacher wanted to see the quiz results, I didn't mention this. If you teachers want to see the quiz results on the end of section, let me go back real quick to that. Here's one. Here it is. So let's say you had assigned take a quiz to students, and students, you've got someone turning in something. Here's how I would, if I were teaching today, I would have to decide, do I want my students to submit this digitally, or do I want my students to print this out? Here's how I'd have them turn in. I'd have them put their name in that box, and I'd click the print button for when they're ready to turn it in. And I can either have them print it out, which is what I would do from here, or I can save as a PDF or Microsoft Print to PDF, whichever PDF option you have. And I would tell them to save it, put their name on it. It says essential physics. That's a little bug that we haven't fixed yet, but oops, I clicked the wrong thing. Let me go back to my window. Let me save it as EP. I would put my name on there, but section, chapter 8, section 3, and then save it. And now I have a PDF document that I can get through my system. Everything's opening on my other screen here. So let me go to my downloads. I think I saved it there. Yeah, there it is. There's my quiz. I would upload this to however I share my digital documents with my teacher. So maybe that's an email attachment. Maybe that's I have Blackboard and I can do attachments, and the teacher set up an assignment, and that would be on your side on the Blackboard. You'd have to set that up that way. And if you wanted to just print out those questions without answers, you can do that to assign quizzes to students too. So you would just go in either as a student or teacher and print this out. Just do a print and do the same thing. Either save it as a PDF and share it digitally with your students, or print it out, make copies for all your students, make multiple versions of this quiz and assign to your students that way. And of course, you wouldn't put your name there, right? But you could just print this out blank and assign it that way too. Okay. I think I was going over the end of chapter. Let me go back. Okay. So one thing I did kind of skip. So here we are at the end of, this is the last section in chapter 8. After the last section in every chapter, right before those end of chapter questions come up, we've got these readings. These are the essential chemistry readings, and they're just something that ties in something that was learned in the chapter to phenomena, to something real, to something students might care about. For example, plastics, dyes, and how do chemists try and be green about creating these things we know are problems in the environment, like plastics, or dyes that can be toxic. So very relevant student-centered readings here at the end. And in the teacher edition, there is like a little reflection piece that students can fill out as they read these to think about, what about that? What do I think about that concept? Or what about that scientist that had those challenges when they were developing this? Or any number of ways to interpret this reading. So students can wonder and reflect about what they've read here. And then after they get through the reading, that ties everything together for them, they get to the chapter review. Again, chapter review, no answers given. So you can see what kind of difficulty you're assigning with the chili peppers. Here are the conceptual questions. These are not calculation based. Students are writing out the answer or the thinking and trying to come up with an explanation. Sometimes if there are numbers in there, it's very, very little analysis of those numbers. It's more identifying the numbers and explaining why did you pick those numbers. And then when you get to the quantitative problems, that's where there's the calculation-based questions. So if your goal is to stay at the conceptual level, maybe you're only assigning a couple of quantitative problems, so this helps you determine which questions to assign. Okay, so again, there's sectioned out by 8.1, 8.2, and 8.3. So because this is stoichiometry, you can see there's tons and tons and tons of quantitative questions for all the sections. And again, these are no answers here, but they will be in the teacher edition, which I'll show in just a moment. Okay, so the whole time here, we've been looking at the student edition. Okay, here's the beginning of chapter, the beginning of chapter 9. You know how we ended the chapter on a note of, hey, what's relevant to you? What might your students care about? And what might they wonder about? The same thing at the beginning of a chapter. We start out with a little story. And that kind of tries to tie in what they've already learned, what they already know, with what's coming up in the next sections in the chapter. So the idea of modeling and model of a car is not a real car, but it kind of gives you an idea of how it works. And here's what we thought the atom looked like before, and so on. It's really kind of the same idea at the end of the chapter. So that's how chapter begins. Then the next page after that introductory page is just a preview of what's coming up. All the pages which you can click to. So let's say that you've just finished chapter 9 and students are like, oh, I really don't remember how to describe the electron cloud. I can find that electron cloud topic and just click it and go straight to that page. So this is nice. It's linked. We've also got the learning objectives listed out for you and what labs go with this chapter. Obviously, all of chapter 9 labs, A, B, C, D, are going to go with chapter 9 in the textbook. And then all the vocabulary here for the whole chapter, which that same idea is if you hover over it, it goes away. But if you click, it sticks. And you could even, if you wanted to copy and paste it, if students need to keep track of vocabulary that way, they can do that. And that's the chapter study guide page. Then the beginning of a section. Here's the beginning of chapter 9. There's this green topic, which is kind of the idea of the entire chapter. Here's an overview of the entire chapter. And now this page, the rest of the page is about this topic. And then each paragraph has a topic as well. Okay. So there's the structure of the ebook. The one thing I didn't show you up here is the search button. The search button appears inside the textbook. So if I click search and I want to find about molecules, that's going to appear a lot. So I have to know exactly what type of molecule information I'm looking for. Let's look at tetrahedra. Oh, there's a tetrahedral molecule here, a tetrahedral shape that has the parent shape with an additional atom coming off. Okay, so that's the search button. And I believe I showed you all of the features of the book. Let me check this. Yeah, we talked about more buttons. Always click them. Try the test your knowledge buttons. Always check out what's on interactive simulations. We looked at the difference between a simulation and a molecule on the hover over versus the equation builder. We looked at take a quiz at the end of section, which is going to give you infinite questions on the quantitative problems, and it will mix up the questions for students. You can use this for homework. And then the questions themselves at the end of section, answers are given, which is why we gave you the take a quiz option there. We talked about the equation builder, learning how to balance and use stoichiometry and set up stoichiometry problems. And that's, we did cover the equation builder. Here are the 4 steps we went over: how to build an equation, how to balance it, how to work through the stoichiometry and see how they're set up. Now, we talked about the molecule viewer. There is an amino acid beads option to look at large molecules like proteins. There are nucleic acids in there there's a biochemistry chapter, so that's why that's in there. We talked about charged surfaces and the molecule library. You can change molecules from the drop-down menu. And again, you can access that either in the textbook or in the lab book at any time. Now the teacher book. So I spend a ton of time in the student book because you're looking at almost exactly the same thing when you're looking at the student book. Let me show you what's different in the teacher book in just a moment. Again, you go to the same web page and your landing page will look the same, but you're going to enter your teacher code. And when you enter your teacher code, it'll give you these buttons. So compare that with students. The student looks like this. It says student, says open book and sign out, and that's all they've got. Teacher says teacher, and they've also got a test bank and an academy button. So let's open the teacher book. Let's look at chapter 8. And by the way, first thing on my landing page, look, I've got this test bank button here. So that's just another shortcut to get to the test bank, which we'll go over in just a second. If I click on help, That help is available in both student and teacher on this landing page. These first two links here, or rather this link, Navigating the Student eBook, that's also available for students. It's a video, very short video. The Teacher's Edition video, that's only going to show up for teachers. Using SparkView software shows up for both students and teachers. And this How Do I YouTube channel shows up only for teachers. And this is helpful if you are an equipment adopter. It'll go through a bunch of stuff on sensors and software in addition to the SparkView software link. You can also access the user guide. This is only available for teachers. It is a help for you. So if you click it, it takes you to the help website. And you can search the help. Like you can't remember how to use the take a quiz. Take a quiz. So I started typing in take a quiz. There it is. Stuff going quiz. There it is. Showed up. Here's how to do it. So it's a searchable help available when you're in the teacher ebook and you click help. And also information on getting help from us and how to log out of the book. Standards is available for teachers and students as well. So let me go back. Okay, so the homepage looks different because of the test bank button is there for teachers. And also, if you were to be at the same one school, you have multiple chemistry teachers at the same school or across the district, it's one code for all teachers. So you want to be very careful about sharing your teacher device with students. Just don't do it. Don't share your teacher device with students or clear your cookies if you do. So what happens is when you log in to this website and you got let me put this one back. You've got your code in there. Every time you open the browser, it's going to remember your code. So don't share your device with students. It remembers the code, it puts a cookie on the computer, and that makes it convenient for you to get to the book and for students too. So when they log in, they don't have to keep putting in their code. It's just going to always open. So be careful with your teacher device. And again, it's going to expire probably at the same time as your student code because when both licenses are purchased, they're almost always going to be the same term depending on what your school district orders. If you're a portal user, you can launch the teacher ebook from the portal. And again, that's included with the portal, whether or not you purchase the licensed student ebook. Okay, one thing I wanted to make you aware of, let's say that you're reading through and you find this cool animation. Let me jump to that page in the book to show what it looks like. You're on page 285, you open this more paragraph. It's talking about trends and, oh, let's hover over this image. And it shows the reaction of water with sodium. That's cool. What if I want to put this in my own presentation? I want to add to the presentation that's included with students. I can right click on it. I can do save image as or copy image and put it into my PowerPoint like I've done here. And look, I've got my animated GIF in my PowerPoint just like that. All the images can do this. Of course, if it's not an animated GIF, it's just a static image, but you can do this anywhere in the book. It's subject to fair use. So you make your own teaching materials, just take our images and put them in your own presentation or use the presentations as we give them to you in the teacher book. Here is the teacher book. Let's look at the stuff that you get in the teacher book. See this yellow bar here? Again, that yellow area means teacher content on the side and on the bottom. Sometimes there's stuff on the bottom, sometimes there isn't, but there's always stuff on the left side. I'm going to go to section 8.3 since we spent so much time there and you're a little more familiar with it. This limiting reactants page again. So on all of the pages in section 8.3, this table stays the same. Oh my, look at all this stuff. This is a lot of stuff. I mean, sections usually don't have this much stuff, but this one's packed. So that's kind of why I picked it. Let's go back to section 8.2. See, there's fewer things in 8.2. Some sections have a few things, like this one has very few items, but other sections have tons of stuff. Just depends on how much support each lesson needs. And this also happens to be an end of unit section. So there's a lot of review for unit 3. I think this is unit 3 or unit 2 rather. So every lesson or section, they're interchangeable at this point when you're looking at the teacher edition, has a lesson plan in PDF and editable Word doc form. And on the lesson plan, you will see the learning objectives for that section or lesson, what students should have already completed in the book or the concepts, the things that are included to help you get through this lesson, whether they're electronic resources or maybe it's a molecular model kit, because there's a lot of times it'll say on the sidebar, it'll say, grab your model kit, build this molecule, talk about this. It'll say stuff like that. So it'll indicate that you need the model kit or a model kit. The electronic resources, these are like assignments and interactives, student work, things you can print out and give to students, and some sample questions for assessments. The dimensions that are mostly covered, there's obviously going to be more than one, but these are the ones that have most heavily hit in that section. Then on the right side, a discussion idea to get the students engaged. Here are the labs that go in this section. This one section has 4 labs. That's really unique. Usually it's 1 or 2 labs, sometimes no labs in a section, but it's almost always 1 at least. So we've got 4 labs. Out of those 4 labs, one of them is an engineering design lab. So make your own airbag. So here's the engineering design project. Lab 8E means design. It's a design and airbag lab. So it's kind of fun, and students get a chance to use the iterative engineering design process and create something using what they learned in Unit 2. There's also sometimes I know you want to integrate more presentation or research skills in your chemistry lessons. Here's an opportunity here, this research and presentation enhancement that goes along with the design project. So here's what you see in the lesson plan. They also are shortcuts to the labs that go in this section. So remember, I could get to the labs either by going straight to the lab in the top navigation, but I can also see which of those labs go with lesson or section 8.3 because they're in this table, and I can shortcut to that lesson % yield. If you look at part 2, on part 2 of the essential chemistry training, we're going to go through this investigation, determining limiting reactants, this stoichiometry investigation. Here's the engineering design project that was listed on the teacher, lesson plan. There are the student version of the assignments in Google slide form. So if you're a Google Classroom user, you can share this with your students. They can fill it out. And so if you want to, you can be a totally digital classroom, or you can use the PDF version, which you can download and print, or you can also be a totally digital classroom here because they're form fillable. So students can type in, you can share this with students through your Blackboard or Schoology and type in answers and save as a PDF or print out. Or you can print out the Word doc version and you can edit it that way and make it your own. I think I forgot to talk about the slide presentation and your lesson plan. So the PowerPoint is editable too. So we've written up some presentations for every section. You can either show the PDF to get a static version of it, or you can edit the PowerPoint version or present that. The slide notes is maybe something you want to print out for students so that they can take notes on the slides, or maybe you grab whiteout and you white out some parts because you want students to be actively writing things while you're presenting the presentation, and this is already assembled for you. Every lesson, every PowerPoint has these pre and post assessment questions. So this is section 3, starts out with these pre-assessment questions. Every presentation does this. What are the questions? What do you already know? Okay, so ask students these questions to gauge their current knowledge. See if there's something you need to hit harder when you're teaching the lesson. And then when you get back to the end of the lesson, reassess with the same questions and see how much they learned. What do you need to reteach before you move forward? So that's pre and post assessment in every presentation. So obviously, when you get down to the student assignments here, there's going to be teacher answer keys. So here are the answer keys in the answer key section for all the assignments for students, including labs. Then there's a summary of the lesson, little tips for teaching. So this is great if you're a new teacher. There's a lot of tips from the authors here. All of us were former chemistry teachers, and combined, the 4 authors, we had over 50 years of teaching experience when we wrote this book. So we've all contributed here. And even if there's an interactive, we write in something on the margin here of like, here's what students should get from this interactive. Then at the bottom, this one reminds you, hey, don't forget to use that pre-assessment to identify misconceptions before going forward. Okay, so those are the resources that you could either click and download if you're on education.pasco.com. But if you're on the portal, So again, this is a subscription-based service, and you went to the Essential Chemistry book on the portal. You can view chapter resources, and you can go to chapter 8 and go to lesson 3, limiting reactants. And if you want, you can just select all the student files and all the assignments, all the handouts, all the teacher files all at the same time. And you can click the bulk download button to get everything at once if you want. So, except you can't, so yeah, that's, this is the way that you do use the portal. It's an easy way to get and share those assignments rather than having to click everything one at a time in the browser. You can just get them all at once in the portal. There. Okay. So we've talked about what you get in the teacher resources, the lesson plans, the slide sets with the pre and post assessment questions, student assignments, which are form fillable. So if you wanted to, you're totally digital, or you can print them out and have students fill them out, and answer keys that go with everything that's presented as a student assignment. The portal also has those same items that are a little bit easier to download and share. So through your learning management system or your single sign-on account. Your lab book is structured similarly in the teacher edition. You'll have that yellow section in the teacher edition that shows you all the resources, and we'll talk more about the lab book if you look at part 2 of the Essential Chemistry webinar. And oops, there. What you will see in the teacher lab, the teacher version of the lab manual, let's look at the teacher lab manual. So here's conservation of mass. This is the first lab in the chapter 8 labs. The picture shows you a preview of the type of equipment that you'll need, and you'll see that this is a traditional lab because there's no pictures of sensors and there's no little spark view icon. So this lab is non-sensor based. It's traditional only. So if you don't have equipment, it's one you can do. But if you look at one that has sensors like this one, there's a picture of the spark view icon and also the pressure sensor. So that's a clue right away. Hey, that's a sensor-based lab. Then on sensor-based labs, if it's a sensor-based labs, we will give you the data file, a sample data file, often the same data that was used in the answer key, as well as a video that we took explaining what's the lab, here's the sensor you're going to use, and other pertinent information for that lab. Every lab, whether it's traditional or sensor-based, has a presentation. And that presentation, whether or not you guide your students with presentations for labs, you might want to look at it because there's something called the think about it question. Like if we look at this one, here's 8D, determining limiting reactants. This think about it slide asks students to think about applying stoichiometry to making s'mores. So that's something that you might enjoy sharing with your students. Then the student lab directions, which you could reuse with a separate answer sheet, which students could individually turn in. Same thing, you've got the slide or the PDF, which are fillable, so you can go all digital if you want, or if you want to modify it, here's the Word version, so you can make it your own. The teacher version of the lab directions, so teacher version will have how to prepare all of the solutions. Here's the directions for making everything. Here, how do I make 0.12 molar sodium bicarbonate? Well, here's the directions. Here's how much to make for 8 lab groups or 26 students working in pairs or 4 liters of, so it always tells you how much it'll make. Then every lab has shortcuts to the reference materials, the lab equipment and tools. So that you could print it out as a PDF or you can just look at it. There's also a shortcut to a SparkView Quick Start Guide, which kind of goes over the key components of SparkView if you're using sensors. A video of how to use SparkView software, the same one that was in the teacher help and student help on the ebook. And lab safety procedures. So the beginning of the year or as needed, here are the safety guidelines. And there's also a safety quiz included in the teacher version of the ebook for safety. So there's all of that. Now, so those are what resources are included in the teacher materials. And also, if you are a sensor user, the software SparkView is also included with your ebook. Okay, so now we're going to look at the test bank. Like I said, you can either get it from the teacher homepage or from the teacher version of your login. So I'm going to go home. Here I am logged in my teacher account. If you're on portal, it's accessible through there too. So I'm going to go to the test bank. Oops, let me go back. I went too fast. I would click on essential chemistry. The first time you log into the test bank, though, it will ask you to set up an account. I think I took a screenshot of that. Oh, I forgot to set up. Well, first time you land on test bank, it will ask you to set up an account. So you should use your teacher email, and you should make sure that you um, that's the email you should use when you sign up, because if you forget your password, it can send it to that same email. So once it'll email your access code once you sign up to that teacher email, and then you can get into the test bank. And that's how you would get in if you're on the portal. There's a launch test bank button for portal users. There are 3 steps to building a test. I'm kind of running short of time, so I'm gonna go as fast as I can to do these 3 steps: design, review questions, and build the test. So I'm in the test bank. I can either choose chemistry or physics, but I'm gonna choose chemistry. Course name, I'm just gonna put course name so you can see how these things, where they end up. Course description, I'm gonna put course description so you can see where it ends up when I build the test. Instructor, and I can put the difficulty at just the hardest questions, or all 3 levels of difficulty. I can choose more than 1 chapter at a time. It separates the questions by section in every chapter, so I can do all of the questions available in chapter 5 if I want, or just some of them. Let's say that I do 5 questions out of each section in chapter 8, and let me build a test based on those 3 sections, 15 question test. Then I can go on to the next test. If I wanted to put student directions and fix any typos that I have there, it tells me the average difficulty is 1.87. So that's not bad, average between 1 to 3. Maybe I want to make it a little harder. If I want to make it a little harder, I can take this question, the difficulty is 2. Let me swap that for a harder question. Now I've changed that to difficulty 3 question, and the average difficulty went up. So I can do that. I can change the difficulty of the test that way. If I don't like the order of the questions, I can take the question and hit the down button to move it to the second question, or move it back up. I can swap to get a different question, or I can delete the question entirely. And I can add more questions if I don't think that's enough. I'm going to keep going, and I'm going to say, okay, I'm ready to build the test, or it's ready to save. Oh, by the way, I could also have hit easier. If I have a difficulty 2 or 3 question, it'll change the difficulty that way. So I'm going to build the assessments. Let's say I want 2 different versions. And when I was in the classroom, I always had weird names like grapes and strawberries for versions. And students would kind of fight over the fruits they got. Just kind of always broke the tension before a test, made it less stressful. I'll just put straw. So I'm going to build this assessment. And I've got 2 versions of this test. It tells me when I made them. I can preview the test. Here's what it looks like. Here's where instructor showed up. Here's where course name showed up. Here's the date that it just puts there, and here's the test version. And that's where those items end up. And I also have that on the slide highlighted to show you where everything ends up as you enter it as you build the test. Let me go back. I know my time's almost up here, so we're almost at 90 minutes. So when you're ready to print the test, you just hit the print button. And you could also, if you have like Canvas, if you have a learning management system, you could export as a QTI version 2.1. I don't know if anyone is using 3.0 yet, but probably going to use 2.1. If you export that, it'll make a version of the test that you can import into your learning management system and do auto-graded tests that way. You would have to take it from there and put it into your like your Schoology or your Canvas that way. The answers are on solution set. Obviously, I can't show that live because I don't know who's watching this recording. So let me give you some screenshots of what the answer key looks like. So the answer key will show you just A, B, C, D answers. But if you click full solutions, it will show calculation and the questions answered with more description, explanations, and step-by-step problem solving as shown here. I've linked them out here, so you can't see them right now, but when you're licensed, you'll be able to see them. Or when you log in as a teacher with your teacher account, with your teacher license, you'll be able to see them. Okay, PASCO Academy, available at education.pasco.com on the Academy button or in the portal. if you have a portal um, subscription, you can get all 3 academies, chemistry, physics, and biology. And what that is, as I explained, is it's something we made during the pandemic, but it's a collection of 3 videos. The first video is for you, the teacher, to watch to decide, "Hey, is this something I wanna watch?" And if it was me, I'd put it on speed, double speed, so I can listen to it, and watch it and decide, do I wanna show this to my students or not? So that's for you, the teacher preparation video. The second video is student data collection, which Roger and I, my colleague Roger, he's the product manager, for chemistry, biology, environmental. Roger and I are lab partners doing the lab as if we were high school students, um, talking through the lab, and this is something you can share with students. So it's us showing the correct way to read a graduated cylinder. It's us wearing goggles with our hair tied back and so on, doing the lab and recording data in SparkView when it's a sensor-based lab. So that's something you would share with your students, and then you can assign the labs to students because they can actually fill out the data. They can have the SparkView file and do the analysis from the SparkView file as if they were doing the sensor lab themselves, but they can do it maybe there's a substitute teacher that day, and here's how you can do a lab with a substitute teacher. Suddenly it's something you can do. Or maybe it's a student had to be out for a sports event and they missed a lab. Well, here's a way that students can get caught up on that lab and not have to come in after school for an hour. They can maybe do the academy version of that lab. So you share that video with them and you share the student files with them. So students are able to complete the lab report, they're able to do the analysis with the data, and you can share this follow-up video if you choose. It does go over some of the answers that we selected we thought that students might struggle more with. So that's an option for you. Check it out. We won the um, educators pick for best of STEM in last year for video-based learning. So again, available chemistry, physics, or biology. Do check out education.pasco.com. If you have a login there, you will see um, the. Let me go on the teacher version actually, so that you can see everything that's there. Here are standards and correlations and more about your product. Here is a video on how to get through the ebook. These are the same as the help videos that are on the help page in the help section on the ebook. This is where you would get software, SparkView software, and also the help for SparkView software. Depending on, we'll talk more about this in part 2. Here's the test bank link, PASCO Academy link. Again, Academy and test bank are also up here. Then there's at the very end here the equipment kits that are available for chemistry and physics. Okay, and back to this. Those are all the resources there. Do take a second to check out pasco.com/freelabs to look at labs beyond what's in our ebook. And do please contact your Pasco rep if you're interested in purchasing the ebook or licenses or the subscription service for our portal or any of the sensors and equipment that you've seen so far. Hopefully I'll see you in part 2. Thanks for sticking with me. And I hope you have a very good school year and good luck to you.